Problem on the test asks us to divide 2x cubed plus 3x squared minus 2x plus 1 by x minus 2. I do not specify a technique, and x minus 2 allows us to use synthetic division. Recall, if you do want to use synthetic division, you have to take the opposite of whatever that number is. So 2 minus 2 makes 0, so the opposite of negative 2 is positive 2. That's what goes up in our little box up here. The coefficients of the dividend go next to it. Is positive 2x cubed, positive 3x squared, negative 2x, and positive 1. Every power of x has happened there, so it's all ready to go. If any power of x were missing, you're going to put a 0 in that spot. For example, if that 3x squared wasn't there, this would be a 0 instead of a 3. Once you get it all set up properly, then it's just a matter of applying the synthetic division technique. Step 1, bring the first number down as is. Step 2, multiply times the number up in the box each time to get the next number up. So 2 times 2 is 4, 3 plus 4 is 7. 2 times 7 is 14, negative 2 plus 14 is 12. 2 times 12 is 24, plus 1 is 25. The number at the end represents the remainder, constant, x to the first, x to the second. So if we then write our solution, 2x squared plus 7x plus 12 is the quotient. And then the remainder term, it's positive, so I put a plus, and then 25 over x minus 2. And that would be the quotient. It should be able to be used synthetic division on the test, so expect that. Just prepare yourself for that and be ready to do that correctly. Number 2, examine the leading term of the function given by the equation p of x equals 2x to the fifth plus 7x plus 1, and determine the far left, far right behavior of the graph of p. If you recall this, the leading term is the highest power term. It's not always the first term, but as you can see, the first term in this case also is the highest power term. The two things that concern me about the leading term as far as establishing far left and far right behavior are the powers evenness or oddness. So the power of this is 5, which is odd. What that tells me is either going to be left down, right up, or right down, or let's go left up, right down. Let's go that. Those are the two choices. If you have an odd power, they're opposite. So left goes down, the right goes up, left goes up, the right goes down. Just know they're opposite. These are the two possibilities. The other thing that I care about is the sign of the term. The term is a positive term. It's positive 2x to the fifth, not negative 2x to the fifth. Positive leads us to what should happen. As we go really big negative, our graph's going to go really big negative. So we go really big positive, the graph's going to get really big positive. So positive leads us to the normal one. Going negative goes negative, going positive goes positive. Abnormal would be going negative gets positive, going positive goes negative. So of the two possibilities, that's how we handle it. If the power were even, your choices are up, up, normal, positive, down, down, abnormal, negative. So again, the fact that it's positive tells me it goes with the normal one. So left, down, right, up. That's how I'd like you to write your answer on that one. Number 3, find the real solutions of this. And this is a problem that happens several times in this test. You have to establish a technique for doing it based on what you're looking at. What I see here, the first thing I always do is go to algebra. Is there some algebraic technique that I've learned through the years that allows me to solve this some way, shape, or form? And the first thing I notice is x cubed, x squared, and x all have a common factor of x. The whole thing set equal to 0. So I can do just a greatest common factor factorization of this thing. And I'm left with x times 2x squared plus 3x minus 5 equals 0. I see this as a factorable trinomial, maybe, but it doesn't look to factor very easily. But it is quadratic, so the quadratic formula is legally used here. So at this point, I'd say x equals 0. And my basic leftover piece here of 2x squared plus 3x minus 5 has to equal 0. And again, maybe it's factorable. It doesn't look easily factored. So then I can go to my calculator and just throw in my quadratic formula program here and type in the coefficients of 2x squared, positive 3x, negative 5. My calculator returns the answers of 1 and negative 5 halves. And just like that, 0, 1, and negative 5 halves would have to be our answers. So we just write those down. So x equals 0, 1, negative 5 halves. For this entire test, if an answer should happen multiple times, make sure you do a multiplicity on the answer. In this case, all the answers happen one time only. The highest power represents the number of answers possible. You can see we got 3 answers. Highest power of 3. That ensures that I've found all of them. Number 4, find the zeros of p of x equals x squared minus 9 to the third times 3x plus 2 to the first times x minus 1 squared, and state the multiplicity of each. So, x squared minus 9 to the third is a factor. 3x plus 2 to the first is a factor. And x minus 1 squared is a factor. So if we take a look at each factor individually, we want to set the parentheses, the group inside the parentheses equal to 0. So if I start with x squared minus 9 has to equal 0, that means that x squared has to equal 9, which means x is equal to plus or minus 3. The multiplicity is going to match the power there. So x squared minus 9, which is x plus 3 and x minus 3, leaving these two answers, happens 3 times each. So each of these answers have a multiplicity of 3. The second factor is 3x plus 2. So if I set 3x plus 2 equal to 0, that gets me 3x equals negative 2, which gets me x equals negative 2/3. And that's just happening to the first power, so that's multiplicity 1. No need to state multiplicity when it's just 1. The final factor, x minus 1, has to equal 0. That means x has to equal 1. This power has 2 on it, so that's going to be multiplicity 2. And that's just how you write the answer. So x equals 3 multiplicity 3, negative 3, oops, negative 3 multiplicity 3, negative 2/3, and 1 multiplicity 2. That is all it's asking for. That problem kind of has the appearance of the even and odd powers of x minus c theorem. It's not asking us about crossing or touching and turning there. So that's what it's asking for, and that problem will ask for the same thing on the test. So find the answers. Be cautious. This is quadratic. It led us to 2 answers. These are both linear. They both lead us to 1 answer. This one had a multiplicity, though. Number 5, use Descartes' rule of signs. As soon as I see these words, use Descartes' rule of signs, I immediately want to create p of negative x. So p of x is important, p of negative x. I'm going to leave myself a little bit of space here so I can do some writing. The odd power terms change sign, so negative 12x cubed. Even power terms stay the same, so negative 40x squared. This becomes negative 13x. Odd power, even power stays positive 30. And what we care about with Descartes' rule of signs is variations in sign from term to term. So the p of x here is written in descending order. All right, x cubed, x squared, x constant. We start off with a positive number that varies to a negative. It varies again to a positive, but then it stays positive. So as far as p of x is concerned, there's exactly 2 variations in sign, which means there's either 2 or 0 positive solutions. Then if I look at the p of negative x, looking for variations in sign, this is negative, it stays negative, it stays negative, it switches to positive. So there's exactly 1 variation in sign from term to term. So there's exactly 1 negative solution. And you count down until you get to either 0 or 1. So I saw in homework some people did, like, for example, let's say there's 5, you get it 5, 3, 1, or 0. It's going to be 5, 3, or 1. You stop at 1, 4, 2, 0, stop at 0. You're either going to hit 0 or 1 if you keep subtracting 2. So if I start off at 2, subtract 2, I get 0. If I start off at 10, I'm going to have to write 10, 8, 6, 4, 2, and 0. If I start off at 7, 7, 5, 3, 1. But again, create p of negative x. Variations in sign mean you start off at something, whatever it is, it changes, it doesn't change. That's 2 variations in sign. Starts negative, stays negative, changes. Once it changes, that's a variation in sign. That's all that you're counting up. That problem shouldn't take too long. The main thing I think people had trouble with was the understanding of what the words meant. So that's how it works. Number 6. This one says find the zeros of p of x. And very much like number 3, except this time there is no common factor. we got a cubic function. We don't have a cubic formula, so this would be more along the lines of the possible rational roots theorem, that technique to find out an answer. So what I would do first is I'd list my possible rational roots. And we get that by taking all the factors of the constant on top and all the factors of the coefficient of the highest power, the lead coefficient there on bottom. So obviously 1 and 2 are the only factors of 2. And plus or minus 1, 2, 3, 4, 6, and 12 will be all the factors of 12. Be careful you don't leave any off. I could make a more detailed list. If I was actually asking the question, find all the possible rational roots, I'd want to actually write it all out as nice, like 1, 2, 3, 4, 6, 12, and then 1 over 2, 2 over 2 is already there, 3 over 2, and so on. So make a list like that. For the sake of getting an answer to this problem, I'm just going to go to my calculator, enter the function, and I can type in these numbers on top over 1, obviously. So let's see, minus 17x plus 12. So 2x cubed plus 3x squared minus 17x plus 12. Then if I go over to my table, nothing's in there, type in 1, works. Okay, so as soon as I find an answer that works, creates a 0, I just do a synthetic division with it. So 2, 3, negative 17, 12. Just like problem number 1, I'm going to do synthetic division. I'm going to bring the first number down. Notice that x equals 1 was the answer, and I put 1 right there. On the problem 1, x minus 2 was the divider, a factor basically, so we're doing if you had x minus 2 as a factor, x equals 2 as an answer, that's what goes in the box. Make sure that if you do these, that the number that you get is what goes there. You don't change the sign on this one. So 2 goes there, 2 times 1 is 2, plus 3 is 5, 1 times 5 is 5, plus negative 17 is negative 12, 1 times negative 12 is negative 12, plus 12 makes 0. This remainder of 0 is what we're expecting. Again, some of you change signs on homework. So synthetic division, if you're dividing, you change the sign. If you're trying to evaluate a functional value, just put whatever the number is, you put the number in. The remaining quotient here is 2x squared plus 5x minus 12, which is supposed to equal 0 still. At this point, it's a quadratic function, so again, I can go back to my quadratic formula. At this point, it's already entered my calculator. Just hit enter, it brings it back up. 2x squared plus 5x minus 12. Make sure you use the negative key, not the minus key when you're typing in a negative number for this. And we get 3 halves and negative 4 is negative 2. Real easy to check to make sure those are actually correct. First of all, 3 halves, negative 4 over 1, those are both listed on our rational roots list. If I type all 3 numbers in, we say all 3 numbers end up at 0 for y, so that verifies our answer. So 3 halves, negative 4, and the 1 we found already are all the solutions. Just make sure you give me all the solutions, not just the ones that are left over once you divide out. So that's what I got from my calculator. It's still an answer that I know right now. Number 7. Given that 3 minus I is a 0 of this, find the remaining zeros. Okay, I can see that it's a polynomial function with real coefficients, and the rule says that if a complex number is a 0 of a polynomial function with real coefficients, that its conjugate is also going to be a 0. And that gets me 2 solutions that if I do synthetic division, I'll drop a quartic function, 4th power, down to a quadratic function. So I simply need to do 3 minus I into 2x to the 4th minus 19x cubed plus 47x squared plus 20x minus 150. And we have our synthetic division program that helps us out with that because the numbers get rather ugly on these. So if I get out of this program, there we go. And I'm going to go to my synthetic division program, number 4 on my list. It might be different on yours, but syndiv is the one you want. Enter. And then degree is 4. The degree is whatever that power is. So it's a degree 4. And it's going to ask for the coefficients, which are 2, negative 19, 47, 20, and negative 150. Then it'll ask for the root, which is in this case 3 minus I again. I'm using this root, the signs are what they are, I'm not messing around with the signs there. And I've got the imaginary number, hit the second button with the decimal point to get I, hit enter. It gives you all this stuff. Now this negative 1.2, e negative 11, that's 0. E negative anything basically on this. They're going to give you a root, it's going to have a remainder of 0, this is where the remainder goes. So if it doesn't show up as 0, just pretend it says 0 there. Use your imagination a little bit, I guess. It has to do with rounding errors that causes it not to be exactly 0, but it is. So what those numbers represent is instead of all this here, it just gives me what goes down here. So 2, negative 13 minus 2i, 6 plus 7i, 45 plus 15i, and then 0. Now you can opt to do the synthetic division on your calculator. Again, at this point, if you do, this is going to be a degree 4 up here, so the next one down is a degree 3. So if I hit enter, it brings me right back to the synthetic division program. Degree is 3 now. Now my coefficients are this one, this one, this one, and this one. So I type in 2, negative 13, minus 2i. Be very cautious before you hit enter that you verify that you have it typed in correctly. 6 plus 7i, and then 45 plus 15i. This time the root I would use would be 3 plus I. I've already done 3 minus I, so I have to do its conjugate. So 3 plus I is what I type in. And that's going to leave me with 2, negative 7, negative 15. And the reason I said you can opt to do it on your calculator, this one's actually not too bad, to be honest. If you wanted to just do it like normal, you bring the 2 down. 2 times 3 plus I is going to be 6 plus 2i. What should happen is, all your i's are going to cancel out. Negative 2i plus 2i cancels. This just makes negative 7. Multiply, you get negative 21 minus 7i. 7i minus 7i cancels. 6 minus 21 is negative 15. 3 times negative 15 is negative 45. I times negative 15 is negative 15i. Cancel, cancel, and these also cancel, leaving a remainder of 0. So it's not really that difficult to do synthetic division the second time. This one here gets really ugly because you get a bunch of binomial multiplications, so you have to FOIL that to get that product, FOIL that to get that product. That gets to be a little bit ugly. This is actually pretty straightforward and simple. So to me, that's takes more time than this. So I would probably do it this way. Maybe for you guys that takes less time, so you do it that way. You do your own time management. That doesn't matter to me, just as long as you give me the correct leftover polynomial here. And what we can see left over is 2x squared minus 7x minus 15, which is supposed to equal 0. Again, the answer they gave me along with this conjugate allowed me to drop the quartic function down to a quadratic function. What's left now is if I go program quad, I've got 2, negative 7, negative 15, which leaves me with x equals 5 and negative 3 halves. That's the answers to the quadratic. We still have the 3 minus I they gave me and the 3 plus I we established. It had to be an answer based on the real coefficients, so conjugate has to be an answer. It does say find the remaining zeros, so if you left this one off, I wouldn't count it wrong, but go ahead and list it anyway. It's good policy. Just that's the function, these are the answers. That would be the best answer in my opinion. But again, if you left that off, those are the remaining zeros. I wouldn't count that wrong. Number 8, find a polynomial of smallest degree that has real coefficients. So once again, real coefficients. That means if any complex zeros happen, their conjugates also happen. It has zeros of 2 plus I, it has a 0 of 1, and it has a 0 of negative 2. And since 2 plus I is a 0, that means 2 minus I has to also be a 0. It does say smallest degree. We got a total of 4 answers, so we have to have a 4th degree polynomial. So if I do p of x equals, I simply have to do x minus each answer. So for this one, if I subtract this answer, I'm going to get x minus 2 minus I. If I subtract this answer, I'm going to get x minus 2 plus I. If I subtract that answer, I'm going to get x minus 1. And if I subtract this answer, I'm going to get x plus 2. So that's how you create the polynomial function. Each problem counts for 8 points. This is worth 3. Just writing out the polynomial like that. You still need to multiply it out properly in order to get me a simplified polynomial function. It doesn't ask for a factored polynomial, it asks for a polynomial, so it's looking for that something x to the 4, something x cubed, and so on. What I would do is I would multiply this stuff here somewhere out of the way. Maybe on a spare sheet of paper, so let's go over this scratch sheet of paper here. I got x minus 2 minus I times x minus 2 plus I. There's a total of 9 multiplications happening here. All the imaginary stuff goes away. So for me personally, when I'm doing this, I just write down the stuff. I do all the multiplications, but I only write down the ones that don't have i's on them. So if I do x times all this stuff, I'm going to get x squared minus 2x plus xi. I don't write it. Then I've got negative 2 times all this stuff gets me negative 2x. Minus 2 and minus 2 makes plus 4. And the negative 2i makes an imaginary number. I don't write it. And then finally, I've got this guy being multiplied by all this stuff. Negative ix cancels. Negative 2 or positive 2i gets rid of it. Negative I squared is actually positive 1. Be careful of that one term. That I squared is going to show up. I squared is negative 1. Minus minus 1 makes plus 1. So altogether off of these two guys, I'm going to get a product of x squared minus 4x plus 5. Then, I go back here, and if you want to make sure that you did that right, it's real simple. You go to your quadratic formula program, enter 1, negative 4, 5, enter, and 2 plus I, 2 minus I, the two roots that were supposed to happen from that polynomial are there, so that's a real quick verification that you can do. For these two guys, it's real simple. It's just multiplying two binomial factors. FOIL it, so x times x is x squared, 2x minus x is 1x, negative 1 times 2 is negative 2. And again, that can be checked the same way. You know, if you typed in quadratic formula 1, 1, negative 2, and we have roots of 1 and negative 2, the correct roots are there. So that just, again, quick verification with the quadratic formula if you want to make sure you got those multiplied properly. Then it's just a matter of getting the overall product. So I'm going to take x squared times everything. I'm going to take negative 4x times everything. I'm going to take positive 5 times everything. So if I do all three of those multiplications, I'm going to get x to the 4th plus x cubed minus 2x squared. Negative, this is a negative 4x times all this stuff, so negative 4x times x makes negative 4x cubed. Negative 4x times x makes negative 4x squared. Negative 4x times negative 2 makes positive 8x. Then positive 5 times everything gets me positive 5x squared. Positive 5x, negative 10. We combine like terms by adding up all the columns. We end up with p of x, our polynomial function we're trying to create here, is going to be x to the 4th minus 3x cubed minus 1x squared. Negative 6 plus 5 being negative 1. The 1's not necessary to be written. 8x and 5x makes plus 13x, and then minus 10. And that is the entire problem done. This would get you full credit. Again, just writing this gets you 3 points. Carrying out some of the multiplication here, like that's probably a point, that's probably a point, that's 5 points, and then carrying all this out gets you the final 3 points. It's probably for partial credit grading. That's kind of where I kind of tend to be. If you get these wrong, but then multiply these together correctly, you'll lose the point for multiplying one of those wrong, but then you get the correct credit for that. So try to get the right answer. It saves me a lot of time in grading, but if you get a wrong answer down here, that's where I'm picking it apart a little bit to find partial credit. Number 9. Find all vertical asymptotes of the graph of f of x equals that. Vertical asymptotes, as soon as I see those words, what I want to focus on is the denominator. And anything that makes the denominator equal to 0 that does not make the numerator equal to 0 is going to be a vertical asymptote for sure. If it happens to make the numerator equal to 0, then you have to maybe do a little bit more checking. But I'm not going to throw anything that tricky. It'll probably just be, at worst, something on the bottom makes the top equal to 0, just throw it out. So if I look at the bottom of x squared minus 3x minus 28 equals 0, This is just a simple quadratic, x minus 7 times x plus 4 equals 0. So that gets me x equals 7 and x equals negative 4. I am looking for you to write them separately. Don't just give me x equals 7 comma negative 4. It's asking for the equation. Anytime it asks you for vertical asymptotes, it wants equations of vertical asymptotes. They're going to be vertical line equations, x equals number. This is one of the answers, this is the other answer, as long as neither one of those answers make the top equal to 0. So if I try 7 first, 49 times 2 is 98. Minus 35 minus 7 doesn't equal 0, so that's fine. If I try negative 4, I'm going to get 16 times 2 is 32, and then negative 4 times 5 is positive 20, minus 7 also doesn't equal 0. So both of those equations are the asymptotes. If you write your answer like this, x equals 7 comma negative 4, I'm going to count off 4 points because you got one answer right, one answer wrong. X equals 7 is the right answer, negative 4 isn't an answer. So make sure you put x equals, x equals. And again, if one of these did make 0, just throw that one out. All right, just scribble it out, make it go away. Number 10, find the horizontal asymptote. Okay, if I'm looking at horizontal asymptote as my goal, what concerns me is the highest power term on top and bottom, and be careful that you find the highest power term. Okay, the highest power term on top is 7x, negative 7x cubed. Highest power on the bottom is positive 4x cubed. Everything else has a lower power. On top we have squared and constant, on the bottom we have first and constant. So the only two numbers that matter to me when I'm finding a horizontal asymptote is the highest power terms. If I take that fraction of just the two highest power terms, I see the x cubes are exactly the same, so I end up with negative 7/4. Y equals that number is the answer. Again, it has to be an equation, not just a number. Y equals for horizontal asymptotes, x equals for vertical asymptotes. That tells me that this graph, as it goes off in both directions, should level out at negative 7/4 height. As far as what else goes on, we could figure that out also, but that's what we're being asked to find there. Number 11, graph f of x equals x squared minus 4 over x squared plus x minus 6. Use an open circle to show the hole in the graph of f. This isn't saying, hey, by the way, there might be an open circle. It's saying there is an open circle to show the hole in the graph. So make sure you find that hole. It's real simple. We start off with the vertical asymptote issue, focusing on just the denominator. Vertical asymptote, we would go x squared plus x minus 6 equals 0. Once again, easily factored, x plus 3 times x minus 2 equals 0, which gives me x equals negative 3, or x equals positive 2 as vertical asymptotes. If I test out these numbers in the numerator, just mentally, negative 3 squared is 9 minus 4 is 5, so this is a vertical asymptote. 2 squared 4 minus 4 is 0, that is not a vertical asymptote. That also tells me immediately that I can simplify this function from what it is to something simpler. So if we take a look at the top is x plus 2 times x minus 2. The bottom we've already factored here is x plus 3 times x minus 2. The x minus 2's cancel, leaving us with a simplified equation. That's what I'm going to type in as y1, is that thing. Also, as soon as I see 2 is supposed to be a vertical asymptote that gets thrown out, I come over here and put a 2 and put OC next to it because of open circle. That's all it is. I can use this equation here to establish what value this should have, but the fact that it wasn't allowed to be used in the original function puts a hole. We're going to put an open circle there. Beyond that, my vertical asymptote was negative 3, so that tells me picking numbers near negative 3, negative 5, negative 4, negative 3.5, negative 2.5, negative 1, and 0 would all be good to pick. So I'm going to pick those numbers to start off with, and that's enough information. Great. If not, I can go back to the drawing board and get more points. So I'm going to clear this out. And again, I'm entering the simplified equation, x plus 2 divided by x plus 3. I'm going to enter all my values that I have in my chart. 2, negative 5, negative 4, negative 3.5, negative 2.5, negative 1, and 0. And I get answers of 0.8, 1.5, 2, 3, negative 1, negative 1, 0.5, and 0.67. Oh, and something I forgot, I already started getting points, but something I forgot to do was the horizontal asymptote. You can either start from the original graph, the original function, which is this one, and focus on the highest powers, x squared over x squared, or even this one, x over x, take your pick. We can see that equals 1, so y equals 1 is going to be the horizontal asymptote. Looking at these points, I don't see anything that's too drastic that wouldn't fit on my graph paper very easily, so I'm going to use a 1-to-1 scale. If I start by graphing my vertical and horizontal asymptotes, horizontal asymptote y equals 1 is right here. Vertical asymptote x equals -3 is right there. The graph should stay confined within those. Again, near zero values where we might reach the horizontal asymptote, but as you get towards infinity, out to the left and right, we should expect it to level out. If I plot the points I have so far, 2, 0.8 would be an open circle value right there. That's not a very good open circle. Let me try again. Just make sure it's drawn big enough that I can see it, that I can tell you meant to make it an open circle. -5, 1.5 would be right here. -4, 2. -3.5, 3. As it approaches the vertical asymptote, it should go straight up or straight down. That one seems to be going up. As it approaches the horizontal asymptote, it doesn't look like it's going super hard down, so I can expect it kind of to behave itself and just start kind of following along the asymptote. It should not breach the asymptote. Again, that should only happen near zero, so as you're going off into the distance, expect it not to cross. These other numbers I have here, we have -2.5, -1 is here. Oops. Right here. And -1, point, oh wait, let's skip -2. Let's put a -2 in also. -2, 0. -1, 0.5. 0, 0.67, a little bit higher than 0.5. Okay, and you can kind of see what's going on here. It's going that way, and it's drifting down. Nothing, in this 0.8 there, nothing makes me believe it's going to go up and over and back down. So I'm believing that it's going to continue on this path. Just lift your pencil up to connect it to that, and then continue on its way. And again, that's what the graph looks like. I expect to see the hole in the graph. I want to see the work where you establish vertical and horizontal asymptotes. Again, it's going to have a hole, so this reduction possibility is there. I want to see your chart filled out. I want to see the graph itself is the answer, but this is the work I would see to establish that you followed through the technique and process correctly. Make sure there's not a break there. Okay. So make sure that hole is very, very visible on your graph. Don't make it like this big, but make sure there's an actual hollow circle there that doesn't look like a filled-in circle. Finally, find the equation of the slant asymptote of this do not graph. So we're not graphing, all we're doing is doing a slant asymptote. All we have to do a slant asymptote is divide the numerator, which is 3x cubed minus 2x squared plus 7x minus 1, by the denominator, x squared minus x plus 1. Synthetic division is not an option on this one. We do have to do long polynomial division. That's the bad news. The good news is it only takes 2 steps, and the second step can be shortcutted. So if I take the first thing divided by the first thing, that's always division. You always divide first by first. That's all that really gets divided. 3x cubed divided by x squared makes 3x. 3x times x squared is 3x cubed. 3x times negative x makes negative 3x squared. 3x times 1 makes plus 3x. Make sure we change all the signs. So 3x cubed becomes negative, 3x squared becomes positive, 3x becomes negative. What should happen to the initial term, 3x cubed and negative 3x cubed cancel because they're opposites. What happens to these is you get what you get. These are opposite signs, so I subtract, I get 1x squared. And then these are also opposite signs, I subtract, I get positive 4x minus 1. And as far as shortcutting the next piece, all I have to do is divide x squared by x squared, which makes plus 1, and I don't have to do all the rest of it because what's left over is going to be a remainder. So but once I get a x term and a constant, that right there represents the structure of my slant asymptote equation. It's my job to remember there's a y equals attached to it. So the answer is not 3x plus 1, it's y equals 3x plus 1. Leave the y equals off, I'll probably take 3 points off. Y equals is very important, otherwise it's just an algebraic expression instead of a linear equation. I'm looking for that linear equation structure. That's what the test looks like. 12 problems, average of about 4 minutes per problem with a regular class period. So I think there's enough quick ones in there. You can spend a little extra time on some of the tougher ones and still get done within the class period.